Question of the week from the Naked Scientists.
Hello and welcome to Question of the Week. I'm Will Tingle. Today's question comes in from listener Wayne, who asks,
if fire needs oxygen to burn and there's no oxygen in space, how does the sun stay burning? Thanks.
Thank you, Wayne. Fire is the result of the process of combustion. As you rightly pointed out, in a combustion reaction, a fuel is heated and it reacts with oxygen to produce oxides, compounds that contain at least one oxygen atom and one other element in their chemical formula. But the sun's energy comes from a completely different process, nuclear fusion. The difference between fusion and combustion is explained by zooming into what's going on inside the nuclei of the atoms of chemicals we're talking about. Here to help me explain is Professor of Astrophysics at the University of Manchester, Philippa Browning.
The sun creates energy in its hot, dense core using hydrogen as fuel, which is available in very large quantities. The nucleus of a hydrogen atom is a single positively charged proton. Through a series of nuclear reactions, 4 protons are forced to combine into a helium nucleus, which is made up of 2 protons and 2 neutrons. These resulting helium nuclei have less mass than the reacting protons, so this produces a very large amount of energy as mass is being converted into energy. We can see this through Einstein's famous E=mc² equation. Fusion reactions can only happen at extremely high temperatures, but the core of the sun is at 15 million degrees Kelvin, which is high enough.
So that's how nuclear fusion works. But what's going on with the chemistry in combustion, and how does it differ?
Atoms consist of positively charged nuclei containing heavy protons having positive charge and neutrons with a similar mass but no electrical charge, as well as light negatively charged electrons. In chemical reactions such as combustion, electrons are shared or swapped between elements, but the nuclei remain unchanged. For example, when coal is burnt, carbon and oxygen combine into carbon dioxide. This releases some heat due to the electron configuration moving to a lower energy state. Nuclear reactions, in contrast, involve changes to the nuclei. These may either be fission reactions, splitting heavy nuclei into smaller ones, which is what we use for terrestrial nuclear power, or fusion, as we've just mentioned, in which small nuclei combine into larger ones. Because nuclear reactions involve the conversion of mass into energy, they release far more energy than chemical reactions. The fusion of hydrogen into helium, as we have in the sun, produces about 1 million times the energy per reaction than a typical chemical reaction, like the combustion of coal.
So, the sun isn't burning like a fire, it's more like a giant nuclear reactor. Fusion doesn't require oxygen because it's not a chemical reaction, and so the sun will keep emitting heat without the presence of oxygen, as it has been doing for the past 4.6 billion years, and will continue for billions more, until eventually it runs out of fuel. But we've got a little while to go until then. Thank you very much to Wayne for the question, and thanks to Philippa Browning, Professor of Astrophysics at the University of Manchester, for the answer. Next time, we'll be answering this question from listener Dan.
Hello, so I've posed myself a question. Had my parents, my grandparents or myself never received any vaccinations, what are the chances that I'd be here to pose this question? Thank you.
And if you think you know the answer or have a question of your own, do drop us a line. The email address is chris@thenakedscientist.com, and why not join like-minded scientifically curious minds on our forum, nakedscientist.com/forum. Until next time, from me, Will Tingle, thank you for listening, and goodbye.
Question of the Week is part of the Naked Scientists podcast. Look us up online at nakedscientists.com.